Project 1.2 Analog Oscillator.
The purpose of this project is to introduce the transistor and how it works alongside other analog components such as the capacitor. Inside this circuit, there are two 1K ohm resistors, two 10K ohm resistors, two 100 microfarad capacitors, so two 5mm LED bulbs, one power jack, two NPN3904 transistors, one single pole double throw slide switch, and three terminal blocks because it's built on a PCB. The reason this circuit is called an analog oscillator is because the two congruent sides of the circuit oscillate between each other in two different states. That's why another name of this circuit is called an astable multivibrator. Inside this circuit, the current starts flowing from the 9V battery source through the 1K ohm resistor and charges up the first 100 microfarad capacitor. As this capacitor is charging, current would flow through this wire all the way to reach the base pin of Q2, which is the second NPN3904 transistor. This opens up its connection between its collector pin and the emitter pin, allowing current to flow through this wire, thus allowing this LED bulb to be connected to ground, lighting it up. Once this capacitor is done charging, the current would then stop flowing and closing this transistor. At the same time, while it's closing, this second capacitor, which is previously discharged, would start charging through this 1K ohm resistor. And that would allow current to flow through to the first 3904 transistor, opening up its connection between the collector and the emitter pin, allowing the first LED bulb to light up. A capacitor does not charge or discharge at a constant rate. The time it takes for a capacitor to charge can be calculated through the formula T equals RC, or tau equals resistance times capacitance. Take, for example, the first capacitor. It needs to go through a 1K ohm resistor to charge, and it itself has a capacitance of 100 microfarad, meaning that after some calculations, we would get that T equals to 0.1 seconds. Now, it usually takes 5 time constants for a capacitor to charge 99.3% of its time, or more commonly known as a steady state period. This would mean that the capacitor is basically fully charged at this point. That's why we should use 0.1 seconds times 5, which equals to 0.5 seconds, or half a second.
This is the analog oscillator, and thank you for listening.